All right, for number 9, we're given this series and we're told to express it using sigma notation. So for sigma notation, let's just start with a big sigma. The Greek letter sigma, we're going to start there. And n equals 1. We're almost always going to start with n equals 1 on the bottom. Now what we need is we need an expression in here. And to find that comes from the explicit formula for an arithmetic sequence. Notice that this is an arithmetic series because we're adding 4 each time. So 5 plus 4 is 9, plus 4 is 13, and so on. So the formula for an arithmetic sequence is a sub n equals the common difference, which in this case is 4, times n plus our 0 term. So in this case, the common difference is 4, and the 0 term, if we're adding 4 each time, to find the 0 term, we take our first term and subtract 4. So the 0 term is going to be 1. So 4n plus 1, that's what goes in here. 4n plus 1. All right, and now the only thing left to do is figure out what goes on top here. To what term are we going to add all of these? And we see that we're going to add until we get to 101. Well, what term is 101? To figure that out, let's just set 4n plus 1 equal to 101. And then solve for n. That'll tell us what term we're looking for. So we subtract 1 from each side, we get 4n equals 100. So divide by 4 on both sides, we get n equals 25. So we're going up to the 25th term. We're starting at the first term, which is 5. We're ending at the 25th term, which is 101. And this is going to be our answer. That is this series expressed in sigma notation.